We're going to start our time today with a little warm up, seeing if you remember what we learned in our last lesson. Now that you've had time to practice, let's see how you did. Find the cosine of angle A. Remember that symbol right there is angle. I'm going to label that angle with a little curved line here. Round answer to the tenths. Okay, we can't forget to do that. So cosine of angle A is ka. So ka toa, adjacent. So we got 19 over hypotenuse. Remember, that's always across from the right angle, but we don't know what that is. So we have experience with this, though, don't we? Um, since the hypotenuse in the Pythagorean theorem is c, I'm going to give it a lowercase c. And for now, I'm just going to put that right here to remind myself to put it there when I'm done. Okay, so we have a squared plus b squared is c squared. Remember, a and b can be either of the other two sides other than the hypotenuse as long as the hypotenuse is c. So you square 12, you square 19, and you add them together and you get 505. We need to solve for c, so we take the square root of both sides, and don't forget, anytime you do that, you include a plus or a minus. But remember, we're dealing with actual lengths here. We cannot have a negative length, not on this planet. So we're going to take the square root of 505. We're going to get 22.472. We want to make it positive, and now we want to round to the tenths. So 22.5. That is what's going to go right here. Don't forget, that's what we're solving for, not just this, right? That was just to get us where we need to be. So the cosine of angle A is 19 over 22.5, and that cannot be simplified anymore. So we're done. Now, today is a short lesson, so it's not going to be too long. So just stay focused for this short time because it is still important. We're dealing with applications of right triangle trigonometry, and that word applications just means we're going to be looking at some real world situations involving these trig ratios, which means what? Word problems, nothing you can't handle. Before we look at some problems, don't forget your calculator always must be in degree mode. If you're on the Desmos calculator, which I highly recommend, it literally shows you right there. It says degree, it has an abbreviation degree, and then it says rad for radian. Okay? And then obviously here shows you how to do that on your handheld calculator if you have one. Let's take a look at a problem. We're given a triangle, and all we have is an angle, technically two angles, because we know a right angle is 90 degrees, and a side. And that is enough to find all of the side lengths. So we know this one, but we need to find this one and that one. Okay, so that's what I'm going to highlight. You can choose to solve either one first. We could do AC or AB. Doesn't really matter. I'm going to go ahead and choose to solve for AC first. And the angle using SOHCAHTOA, remember you don't want to use right angles, so we're going to use angle B there, aka 35. So we're just going to try something and let's think about what's going on in relation to this. We want to use SOHCAHTOA or TOA, and we want to involve this side, this angle, and we're going to need something else too. So let's see which one of these it is. So opposite over hypotenuse, there's two unknowns. We don't want two unknowns, we just want one. Adjacent over hypotenuse. That's all good, but we're not involving this side at all in that problem solving. So it looks like it's going to be TOA, opposite over adjacent. That's going to give us the one unknown here. Okay, I'm just going to call that lowercase a. We have the one unknown, and we know the 35 degrees, we know the 12. So if I do tangent of 35, I get a over 12. That is an equation with one unknown variable, so we can definitely work this out. Tangent 35, if you plug that in your calculator, you're going to get an actual number. So don't let that throw you off. That is part of your equation. And to get a by itself, how would we do that? Well, you multiply everything times 12. So on the left, you get 12 tangent 35. On the right, the 12s cancel out, isolating that a. And now we can just plug this in to our calculator. So the side length of side A there is going to be, let's see, 8.4 when we round to the nearest tenth. And that makes sense because it's visually it looks a little shorter than this side. So far it's not seems logical, right? And we need to find the other side now. So let's get rid of all of this. We're still focused on this angle. We're using SOHCAHTOA in relation to that angle to find this side. So we need to involve numbers we know and that side. So there's two ways we can do this. You could use the Pythagorean theorem, or you could use SOHCAH or TOA. It's actually going to be, I don't know, let's see, opposite over hypotenuse. Yeah, it looks like it's going to be sine because we know the opposite now. We don't know the hypotenuse. You could do that. But what I'm going to do is I'm going to use the Pythagorean theorem. I like that. So we have a squared plus b squared is c squared. We know that. We've written it down before today. So I'm not going to write it down, but I'm just going to write down the values. 8.4 squared plus 12 squared is c squared. This is going to be a lowercase c. Okay. So once again, we square those and add them together. You're going to get 214.56. And just like before, square root both sides, plus or minus. So C is 214. Oh, sorry, not 214. 14.6. And is that longer than the other sides? It is. So it's so far, it seems like we did everything correct. Now we have a bit of a word problem, no visual, but you can make your own, can't you? Given ABC is a right triangle, right away I would draw my right triangle. ABC, and we don't want to put the ABCs on the corners yet because we got to see what else is happening. Right angle B, so B is here, right angle. AC is 15. Well, we can make this A or that A and the other C as long as one of these is A and the other is C. They're saying AC, the distance from A to C is 15 centimeters, and the measurement of angle C is 34 degrees. Looks similar, right? We know one side length, we know one interior length, and they want to know what is BC right here. So let's see if you can do it now. It's done just like we did a moment ago. Okay, so we want to involve this angle and this side and this side. So what are we gonna do? Let's try cosine. Cosine of 34 degrees. Adjacent, that involves that side. Unknown. I'm just going to call that B over Ka over hypotenuse. 15. There we go, just like before, right? And if you remember from earlier, you multiply everything by that denominator to isolate that variable. Now work this out on your calculator, and you're going to round to the nearest tenth once again to get 12.4. And that is shorter than our hypotenuse, which we want. All right, let's look at a word problem now. A flagpole. If it's a word problem and they give you visuals, why not draw it? So just a quick flagpole here. Okay, a little windy day there. And of course, there is the ground. A flagpole creates a 73-foot long shadow. So the shadow would be on the ground right here, right? Spanning 73 feet. And they're saying the angle of elevation from the end of the shadow to the top of the flagpole is 48 degrees. Looks similar to things we've been looking at, doesn't it? How tall is the flagpole? So this is what we want to know. Round your answer to the nearest tenth. Try it out. Okay, let's see. Let's just start with sine. If you're not sure, SOHCAHTOA. Go with sine, then cosine, then tangent, or just pick one at random. Let's try sine. Sine of 48. So is opposite over hypotenuse. That's two unknowns. We only want one unknown, not sine. Let's go with cosine. Ca, adjacent, hypotenuse. That has only one unknown, but that doesn't involve this side at all. So that would lead us to the right place, but that would give us more work because we need to do the Pythagorean theorem as well. So what's really going to work here is tangent TOA opposite. That involves our unknown side. I'll just put O for now for opposite. Well, that looks like a 0. So let's just make it an X. Opposite over adjacent 73. Just very similar to before, right? Multiply everything times that 73. You get 73 tan 48 is X. And you work it out. You round to the nearest tenth, and you get 81.1 feet. If this is challenging for you, the good news is, if you think back, a lot of these problems are the same, right? It's very repetitive, it's very similar. It's not like factoring where there's a million different, well, not a million, but many different types of ways to do it. This is very straightforward. Okay. So, like I said, this is a short lesson. There is a quiz on this, the 7.03 quiz. So make sure you study, watch this again if you need to, use the OLS resources, and take it when you're ready. Remember, you get 3 tries for all quizzes, and I hope you do well.